Hi, you guys. I am going to try this loom feature for the first time. You probably have had other teachers do this, but we are going to be just filling up some notes in our packet, and it's in this BP2 notebook. So I'm going to pull it up virtually so that you know what I want you to get out and what page to get to. Remember, all of these reference materials are available in Google Classroom, and we're looking down here, and it's notebook for BP2 packet. So this is the one I'm wanting you to pull up. And once you do, we'll take a look at what page number I want you to go to. And also, while that is getting pulled up, I am going to open up the PowerPoint. So we've got both of those ready to go. Okay, so we are going to be filling out. Remember, you ended off the last time we got together filling out this information here. I am going to have you pause out on this demo. You're not going to have this part filled out in your notebook because I want to wait until I get back. It's going to happen someday. And I want to do this in person with you guys. It's pretty cool to watch, I think, at least. But remember, I'm a science nerd. But here is where we're going to start. So we're going to fill out some information that deals with something that's called grain and grain boundaries in a polycrystal. So this would go with the crystal that you guys started growing probably yesterday for most of you. The copper crystals that we are growing in the test tube with using the iron nails. And if you've been in a chemistry class, what we're doing is a single replacement reaction. So we're reacting iron with copper sulfate, and eventually the copper is going to come out of the solution, go on to the iron nail. But the reason we put that salt in there is it's called a salt bridge that we're creating, and the copper reaction then goes really slow, and you're going to get to see the copper actually crystallize and form these dendrite-looking formations on them. So it's going to have a lot more of refraction with light. It's going to look more like an ice crystal whenever you think about how that can really refract light and be really pretty and glittery. So we're going to get to see that because we're making tons of tiny little crystals. But we're going to work on a little bit of vocabulary with this. So I have this out. I'm going to get my PowerPoint up and going. And the only thing I'm gonna push pause just. Okay, I just had to find it here. Sorry about that. So in your notes, this is going to be a pretty short video. So hopefully you guys get to get outside and play a little bit. The weather is just absolutely gorgeous this week. Take advantage of it. But here is where I want us to be. Let me get my big old face out of here, or at least up here, huh? Okay, so, oh man, might not be a good place to put me. Right, maybe right there. Okay, so when we're looking, this is for polycrystallines. Remember, most of what we work with is a polycrystal. It's very hard to grow a single crystal. Polycrystal is much easier to grow. And there's certain language we want to look at here. So if we were to take a blown up version of a polycrystal, so think we're taking this crystalline structure right here, and truly when it begins to crystallize, like the copper that you guys are growing, we are creating a uniformity here, but at some point we hit a little bit of chaos and we create the different matrix right here, and a third matrix here, and a fourth one here, and a fifth one, and so on and so forth. So we've got some language we want to talk about. Each one of these separate tiny little crystals are given the term grain. So the name given to tiny multiple crystals that make up the polycrystal, they are formed by individual crystals that start growing in different places and then meet up. So each one of these tiny little crystals is called a grain. Now, the line where one grain meets another grain, so one teeny little crystal meets another teeny little crystal, that's called a grain boundary. So the definition of a grain boundary is where grains meet up in a solid. So smaller crystals are going to have more grain boundaries, and these grain boundaries, material scientists have found, really affect the physical properties of the solid, and they can manipulate the grain boundaries to end up having different properties depending on what the application is for that material. So we're going to get kind of good at being able to recognize grains and grain boundaries and what that means. This right here is just a two-dimensional picture. It's another graphic trying to show you. So, each one of these individual pieces, if we were to take that copper that we're growing and able to do like a cross-section of it, then we would be able to see something like this. And eventually you're going to. So each one of these individual pieces are grains, and then the lines we call grain boundaries. Same thing over here. So here we have 1, 2, 3, 4 different grains, and these lines in between are called grain boundaries. And these tiny little dots, that's the atoms that are aligning to form a crystal-like lattice, a crystal structure. So that's a two-dimensional representation. This graphic, if you turn your paper over, I believe this is where you're going to see this. And this just tells you the progression of how grains form. And you're going to get to see this here fairly soon. We're going to be doing a lab where we're going to grow crystals and get to look at them under the stereoscope and watch that crystal form. So in A, the crystals just began. And this is how we're going to see this polycrystal eventually form. So over here, they begin to get bigger and bigger and bigger until eventually they kind of collide into each other, and they're going to keep growing until they fill that spot. So here we've got individual grains, and then the lines that go in between are called grain boundaries. Okay. I have horses going through my front yard again. Okay, so over, is that Maya? Oh, it is. Sorry. So here, two-dimensional view, we're going to get to see again. Oh, get my big old face out of here. Let's get over here. Oh, I'm going to get interrupted again by my other daughter, you guys. Hey, Zoe, I'm doing a lesson right now. I'm trying to record myself.
Who is Kenzie with?
I'm doing a lesson right now. I'm recording myself. She's with Molly and Maya on a quick little trail ride. Okay. It's always fun here at the farm, kids. Okay, so this is a two-dimensional view of, this is actually copper where we're looking at it under a microscope. And each one of these different shadowing shapes we would call a grain. The whole thing's a polycrystal, and along the lines, that is called a grain boundary. And again, those type of things make a difference in the physical properties of a certain material, and we can manipulate them to change the grain boundaries. This is the reality. This is a three-dimensional view of what's going on. And so when those crystals are forming, they're obviously three-dimensional pieces. And so I really like this graphic to help you understand. It's like this perfect jigsaw of all of these different crystals. As they grew, they just ran into each other and formed that space almost beautifully and perfectly. So we're going to be playing more with that, what that means. There's some vocab and language that we've never heard of before that deals really just with this type of science and how that can impact properties, use, application, all of those things. But like I said, this is a quick lesson, not a lot to fill in. I hope to see you guys Thursday, and everybody take care.